Hello students, now here in this video let's start special cases in assignment problem. Special cases in assignment problem. Special cases in assignment problem. So now here first case, maximization in assignment problem. Maximization in assignment problem. So here sometimes we want the assignment to be such that the total optimum value is maximum. Total optimum value is maximum. For example, total profit. If we have to gain, then sales, then outputs, etc. To solve maximization in assignment problem, first of all we have to convert given cost matrix into minimization cost matrix. Just like the transportation problem, in that one also a maximization type of problem, we will convert the cost matrix into minimization cost matrix by subtracting all elements from the highest element there. Now here this can be done by subtracting. This can be done by subtracting, same like a transportation problem, subtracting all elements from the highest element of the matrix or another way is here multiplying by -1 to all elements of the given cost matrix. Now let's solve example for this. Remember this, maximization type of assignment problem we will convert into minimization type first. By how does we can do that? By subtracting all elements from the highest element of the matrix, or either by multiplying by -1 to all elements of the given cost matrix. These are the ways. Now let's solve the example using both the ways. Now the example is three different aeroplanes are to be three different aeroplanes are to be assigned to handle three cargo consignments with a view to maximize profit in lakh rupees. The profit matrix is given to us. Three different aeroplanes we have to assign to handle three cargo consignments with a view to maximize profit. We have to maximize the profit, and the profit matrix is given to us. Here the aeroplanes, here this aeroplanes A1, A2, A3. Here cargo consignments. C1, C2, C3, having the cost 145,233,312. Now what the question says? Question is that work out the optimal assignment plane. Now solution for this. Now this given problem is of maximizing the total profit. So to solve it, we convert the given cost matrix into minimization by subtracting all elements from the highest element of given matrix. What is the highest element here? Here it is. What was the highest element here in this matrix? Here it is 5. So we will subtract each and every element from the 5, and then later on we are solving it. Therefore the cost matrix of minimization assignment problem is what does it? It will be here. It will be, we have to subtract each and every element from this 5. So 5 minus 1 we will get 4 here. It will be what? 1 here, 0 here, 3, 2, 4 and what? 3. This is our minimization type assignment problem. Now here it is balanced since number of rows equal to number of columns. Therefore, this AP is balanced. This is balanced AP. Now let's do subtraction for columns and subtraction for rows. Subtraction for columns. Subtraction for columns, then we get the matrix. It will become what is the minimum in this column? 2. So subtract 2 from each and every element of that column. So 2, 1, 0. Here the minimum is 1. So 0, 1, 3. Here minimum is 0 itself. So it is as it is. Now later on, let's do subtraction for rows. Subtraction for rows. Because the second row doesn't have a 0 here, so we need to do it. So subtraction for rows, it will become, now this first row remains same because it has a 0 and that will be the minimum there. So it remains as it is. Second row having the minimum element 1, so it will become 0, 0, 2. This one also, third one remains same. 0, 0, 1 is here. 1 is here. Fine. Now this is an initial basic feasible solution. So let's do the assignments. Now here this row wise, if we go row wise, then this one have a 2 zeros, this is also have 2 zeros, but the third row having a 1 0. So let's assign it and cross corresponding column 0. Now again we will assign this cross corresponding column 0, and later on lastly we will assign this one. As such, this is an optimal solution. What can we say? First of all, it is initial basic feasible solution. When we get the initial basic feasible solution, if all the rows and columns have a 0, then it will be an initial basic feasible solution. And now as in each row and columns have an assignments, therefore it is an optimum assignment. It is an optimum assignment. Okay. Now how does the assignment was done? You know, these are aeroplanes A1, A2, A3, and these are cargo consignments C1, C2, C3. So A1 is assigned to C3, A2 is assigned to C2, and A3 is assigned to what? C1. These are the assignments. So optimum assignment schedule is what does it? A1 is assigned to C3, A2 is assigned to whom? C2, and A3 is assigned to whom? C1. Okay. Now if we have to form minimum profit, then minimum profit is obtained from minimization cost matrix. Here this will be our minimization cost matrix, which was obtained from the given original matrix of maximization type. Fine. So if we want minimum profit, then it is how much? 1 into A1 is assigned to what? C3, so this cost 0, plus 1 into what? A2 is assigned to C2, so this is our cost there, plus A3 means what? A3 is assigned to C1. So 1 into what here? This is 2. So total how much here? 4. This is rupees, but this is given in lakh. 4 lakh rupees is this. This is in lakh given to us. Minimum profit is that one. But we want a maximum profit. In problem it is mentioned we want a maximum profit, and this is our maximum profit cost matrix is given to us. This is original one. Okay. So maximum profit is that will be what? 1 into what? 5. This position. This one and this one. So 1 into 5, 1 into 3, 1 into 3. 1 into 3 plus again 1 into 3. So how much is this? 5 plus 3 plus 3. So 5 plus 3 plus 3. So 3, it will be 11. So 11 lakh rupees. This will be 11. So 11 lakh rupees is our answer here. This will be maximum profit. That is the required answer in this problem. Now the same problem let's solve using another way of to getting the minimization cost matrix, that is or multiply by -1. Multiply by -1 to all entries. Multiply by -1 to all entries. Let's use this one to obtain the minimization cost matrix first. Therefore the cost matrix of minimization assignment problem is what does it? It will be, now look at, this is the cost matrix given to us. Now we have to multiply each element here by -1. So let's write that matrix. What does that? It will be, look at here, let me write it as such. That matrix will be we have to multiply by -1 here. So it will be -1, -4, -5, -2, -3, -3, -3, -1, -2. Now same thing later on we have to do. This will become minimization assignment problem matrix. Now the same procedure we have to do: subtraction for columns, subtraction for rows, and then do the assignments. So let's do subtraction for columns. Subtraction for columns. So what does it will be? The minimum is what? -3. So subtract -3 from -1. This one we have to do. Subtraction of -3 from -1 we get 2. -2 minus of -3 will be 1 and 0. Then here the minimum is -4. So 0, 1 and 3. Here minimum is 5, -5. So 0, here 2 and here 3 we get. Okay. Again what happened? We won't get a 0 in this second row. So we need to do subtraction for rows. Subtraction for rows. So by doing subtraction for rows, what we get? The matrix will be, look at the first row and the third row remains same because it has a minimum element 0. Now this one having minimum element 1. So 0, 0, 1, 0, 3, 3. Again while doing the assignments, what we get here? 0 is get assigned. This will get crossed, this will get assigned, this will get crossed, this will get assigned. The same positions we get if you look for the previous part. Here the previous part, subtract. Here this one we have done by subtracting each element from the highest element. The same positions we get the assignments. Here also at same position we get the assignment. So assignment schedule is what does it will be A1 is assigned to C3, A2 is assigned to C2 and A3 is assigned to whom? C1. Therefore the maximum profit is what? Again same, 1 into 5, same position, so same costs are there, 1 into 5 plus 1 into 3 plus 1 into 3, so that will give us 11 lakh rupees. Now from this problem of maximization type, I thought that you observed either by subtracting each element from the highest element or multiplying by -1 to all entries, anyhow we get the same answer. Okay, so here both the methods are work. Okay, but in TP we are using the subtraction of each element from the highest element to convert it into minimization type of problem. Okay, here both the things are worked. Now let's solve one more problem of this kind. Example, a marketing manager has 3 salesmen and 3 sales districts. Considering the capacities of salesmen and nature of districts, the marketing manager estimates that sales per month is rupees 100 for each salesman in each district would be as follows. Now what does that? It will be here salesman and here districts are given. So 1, 2, 3 and what? 4. Salesmen A, B, C and D are given. The costs are 42, 35, this is in 100, 28, 21, 30, 25, 20, 15, 30, 25, 20, 15, this is 24, 20, 16 and 12. Now question is that find the assignment of salesman to district that will result in maximum, that will result in maximum cell, that will result in maximum. So now solution. Here the minimization assignment problem cost matrix is, it is of maximization type. So first of all we will obtain this minimization type of assignment problem cost matrix. Later on we go further. Fine. So it will be the highest cost is here how much? 42. So we will subtract each element from 42. So here it is 0, 7, 14, 21. Here it will get 12, 17, 22, 27. Then again 12, 17, 22, 27. Here 18, 22, 26 and 30. This is our minimization type of cost matrix. Now subtraction for columns. Subtraction for columns, we get the matrix will be now the first column remains same because minimum is what? 0 here. So 0, 12, 12, 18 as it is. Now the second column having the minimum element 7. So we will subtract 7 from everywhere. So 7, 10, 10 and what is here? 15. What is minimum here? 14. So 0, 8, 8 and what is here? 12. Again minimum is 21 here. So 0, 6, 6 and here 9. This is now again this is not an initial basic feasible solution because the second, third and fourth row doesn't have a 0. So we need to do subtraction for rows also. Let me do it here. Subtraction for rows. Subtraction for rows. So from that we get the matrix. Now here the first row remains same, 0, 0, 0, 0. Minimum of the second row is 6. So subtract 6 from everywhere. 6, 4, 2, 0. Here also 6, 4, 2, 0 we get. And here what? The minimum is what? 9. So 9, 6, 3 and 0. So now each row and column have a single 0. So let's do the assignment here. Now the first row having 4 zeros, second having only 1 0. So let me assign a 0 here. These are get crossed. Fine. Now no other row having a single 0. This column have a single 0. So we can cross these one. Only 2 are get assigned. So here this is not an optimal solution. The number of lines passing through all zeros are only 2, that is not equal to 4 order of this matrix. So this is not an optimal solution. Now here we can easily observe this one by means just by inspection we can do the lines here, but let me use the ticking procedure. So in ticking procedure we have to tick the rows of unassigned 0. Now this row having a assigned 0, this one having a assigned 0, this doesn't have an assigned 0, so we will tick them. Then corresponding in those rows the cross 0 column we have to assign. So we will tick the cross 0 column. So I will tick this column. Now in this tick column we have to look for the assigned 0. So this is an assigned 0 here, so we have to tick that row here. So now after that we have to draw the straight lines from unticked row and ticked column. That is our ticking procedure. Now from this what we get, the minimum of these one is how much? 2. So we have to add that 2 at this intersection position, and we will subtract that 2 from these remaining entries, remaining uncovered entries which are not covered in these straight lines. So from that what I get the improved matrix. Improved matrix is what does that? It is we will add this 2 here. So this is 0 0 0 as it is. Here it will become 2. Here we have to subtract from these entries. So 4 2 0 4 2 0, and here will be 7 4 1. Here these zeros as it is. So now I will do the assignments again. So now this row having a single 0, so let's assign it. These are get crossed. This one having a single 0, so assign it. These are get crossed. Now this column having a single 0, so this is get crossed. Only 3 assignments again we have done. So this is not an optimal solution again. Let's use a ticking procedure again. So now we will tick the unassigned row. In unassigned row, these are 2 cross 0. So tick those columns. In ticked column, this is an assigned 0. So I will assign this, tick this row. Again in ticked column, this is an assigned 0. So I will tick that row again. So now this is completion of ticking procedure. Now we have to draw the straight lines from unticked row and ticked column. So minimum number of lines passing through all zeros are 3 again. So this is not an optimal solution. So again improve the matrix. Improved matrix is again, what does that? It is from here. Okay, so what it is, the minimum of uncovered entries are what? 2. So again add that 2 at intersection position and subtract it from uncovered entries. So intersection position are these one. Look at this. So 0 0, this is 2, this one will become 4. Here we have to subtract, so 2 0. Here these are as it is. Okay, what is here? 2 0, these are as it is. This is 5, this is 2, this 1 as it is, 0 as it is. So now I will cover this 0 in a cross, in a square. This is get assigned, then these one we will cross. Okay, later on this is get assigned, this is get crossed. Now here we have a choice. So we can do the assignment here, then this is get crossed, and then do the assignment here, this is get crossed. Or either you can assign these 2 also. Here you have a choice. You can go for that. Now, but this is an optimal solution. It is an optimum assignment. It is an optimum assignment here. Okay, so now what is optimum assignment schedule? Optimum assignment schedule is salesman and district. So salesman A, B, C and what? D. Salesmen are A, B, C and D, and the corresponding districts to where we have been assigned. So this is A, B, C, D. This is first, second, third and fourth district. So A is assigned to first district, B is assigned to second, C to third and D to fourth, or these can be interchanged. Fine. Now what is maximum cell? We have to determine maximum cell here. Maximum cell is equal to what? 1 into what is that original matrix? In original matrix For first district having a cost is what? 42. Then plus 1 into what? 25. Again plus 1 into 20. And plus 1 into what? 12. So it will be how much? 42 plus 25 plus 20 plus 12. So it is 99 units, and that will be 9900. It is given in hundreds, right? So this is 9900 per month. This is an optimal sale here. Okay. So this is about the maximization type of assignment problem. In next video we will see unbalanced assignment problem and then maximization in unbalanced assignment problem also. Okay. Also further we have to look at for alternate solution and restriction on assignments, that is prohibited assignments. I will explain that time this one. These 2-3 topics are left only. Okay. Thank you.